So in last session, we have covered the hardware part of our problem, that is interfacing 8255 with 885 in I/O mapped and turning the LED on and off. So in this session, we will see the software part, that is the programming. Now here we'll have the flowchart first. Now what is that flowchart is there? That is like this one. So we have to first initialize the 8255 for our requirement. Now since port A is used as output, accordingly we have to write the controlled word format. Here we'll assume that port A is used in simple I/O mode. So if we look at the control word format, these bits, so the first bit is for I/O mode, that is 1. Now the next two bits are port A in mode 0, that is 0 0, and we need port A as output, so D4 bit must be equal to 0. So we are not considering the next 4 bits. Okay, so whatever the hex code is there, that is 80H. If I use this don't care pins to be 0 0. So very first requirement is how to initialize the 8255. Now the next thing is, since I want to turn LED on and off, so just how to control a single bit. Now what we have assumed is LED is connected in common cathode and that is connected to PA0 pin. So to turn the LED on, that PA0 must be equal to 1. So we will write instruction to make PA0 equal to 1. Now that LED should be turned on for some time, so hence we will call for some delay routine. Now after that delay, how to turn off the LED. So that means how to make PA0 line equal to 0, and again how to wait for some time, and this loop how to repeat so that I can have on and off of the LED. Now whatever the address map is there, which is based on the hardware that we have covered, port A is selected with hex address 00, whereas the CWR is selected with 03. So what is this required format is there? 80H, which is used to initialize port A as output, should be taken in controlled word register. Okay, that means I will just give you the instructions. Now first two instructions, so I will take 80, that is the control word format, in accumulator, and I will display at controlled word register. So meaning of these first two instructions is we have initialized 8255. Now what I want to do here is I want to control PA0. So what I will do is I will take that 01, that is 400000, then 0001. That means that PA0 bit is equal to 1. Now I will send at 00. So this 00 is port A address. Then I will call a delay. That means this LED will be turned on for that specific time. Now then I will make PA0 line equal to 00 by taking the format 00 in accumulator, and again I will send that 00 in that 00 at port A. Okay, that means here my address is again out 00H, and again I will call for a delay. Now since I want to continue the loop, I will go for jump up. So this JMP is the unconditional jump instruction. So again I will take 01 in accumulator and display at 00 so that LED will be turned on. So in this way, just by writing this simple program, we can turn the LED on and off. Now here, this is my main program. Now what is the subroutine I need? That is nothing but the delay subroutine. So if we just focus on the delay subroutine, here I have used a register pair to perform the delay operation. So the first instruction is load extended register pair BC with some 16 bit count. So how much delay we required, based on that I will find the value of this 16 bit count. So this 16 bit register I will decrement with the instruction DCXB. But here DCX instruction will not affect the 0 flag. So in order to check whether this BC pair becomes equal to 0 with successive iteration, what logic we have to use is I will take the contents of B in a register A, then I will logically OR the contents of C with A. Means what I'm doing is to check whether the initial count is equal to 0 or not. I'm ORing B contents with C. Now the OR operation is when both inputs are equal to 0, then only output will be 0. That means when the B contents, B register contents and C register contents are equal to 0, then only 0 flag will be set and program will come down. That means for the first iteration, when I'm ORing C, 0 flag is resetted, so the again program goes up, then the DCX decrement the count and it will repeat. And when B and C contents are equal to 0, then 0 flag will be set and program will return to the main program. So for the first return, now the program will come here. Again that 0 0 will be taken in accumulator and it is displayed at port A. Now here I am turning off the LED. Now that turning off, LED turn off, I have to retain for some time. So I will call the delay second time. So in this way, with this small program, what we can do is we can control the turn on and off of LED. Okay, so if we just if we just check both the parts, part A and part B, then our total problem, that is interfacing 8255 with 885 in IO mapped IO and writing the program, is over.